between the implant and the surrounding bone. Low-density bone implant sites have been pointed out as the greatest potential risk factor for implant loss when working with standard bone drilling protocols. Clinical study with consecutively placed implants that were immediately loaded showed a higher failure rate in low-density bone, reinforcing that the primary stability is a major determinant in the success of immediately loaded implants. Among these, resonance frequency analysis has been revealed and widely used as the most successful method to assess primary stability because of its easiness, accuracy, and non-invasiveness. The implant-bone interface is measured based by resonance frequency, which is the reaction to oscillation exerted to the implant and is expressed as implant stability quotient. On the other hand, mechanical tests such as insertion, torque, and value of push-out test showed positive correlation to the primary stability. Hence, non-invasive measurement methods have also been introduced for the diagnosis and prediction of immediate and the long-term implant stability. Studies have shown that the measurement of removal torque strength was a useful indirect biomechanical method to evaluate the bone and implant interface. This preclinical trial done to compare the evaluates the primary stability and removal torque measurements of short dental implants in different dimensions. Materials and methods: fresh 6 years bovine ribs from middle part of the rib procured from the pusher shop were used for the study. They were cut into 6 centimeter long pieces and 1 centimeter thickness, and total of 20 bovine rib blocks were prepared. The cortical bone was removed until it was about 1 millimeter thick in order to make it mimic to type 2 bone. 20 T5 implants manufactured by Nucleus have used in the experiment. We classify it into 2 sets. First one, 10 short implants with a diameter of 4.8 millimeter with 2 different lengths, 5 and 7 millimeter, were used to assess the resonance frequency and removal torque value. The second set is 10 short implants with a diameter 6.2 with 2 different lengths, 5 and 7 millimeter, which were used for comparison. After installation, the ISQ was measured by using of a resonance frequency analyzer. The osteotomy sites were prepared according to the manufacturer guidelines. After implant insertion, the magnetic wireless RF analyzer was used for direct measurement of the endosteous implant stability. The RF analyzer technique analyzes the RF range 110 to 10,000 hertz of SmartBig, which can be attached to the implant. The probe of a wireless RF analyzer was held perpendicular to the implant as indicated by the manufacturer. The RTV of each implant was measured using a digital torque MGT50 digital torque gauge instrument. The peak force measured at implant loosening was scored as the torque out value. We used analysis of variance ANOVA. P-value less than 0.05 were assumed to be statistically significant. Going to the results, the mean values and standard deviations of resonance frequency measurements are shown in this table. If you want to take a look, and I will go to the next slide. Implants showed ISQ values of 45.08 plus or minus 2.29 and 46.45 plus or minus 1.6 respectively for 5 and 7 millimeter. For the 6.2 millimeter implants, the ISQ values were 50.5 plus or minus 1.05 and 51.57 plus or minus 2.06 respectively for 5 and 7 millimeters implants. We can see also the same results in this figure. Even though the values were higher for 7 millimeters in both groups, it was not significant. However, when it showed significant difference, p-values less than 0.01 between the 4.8 millimeters and 6.2 millimeters diameter implants at both dimensions. The mean values and standard deviations of the removal torque measurements are shown in this table too. The removal torque measurement showed no significant differences between 4.8 and 6.2 millimeter implants with 5 and 7 millimeter lengths. The removal torque values show significant difference with the different diameter of the implants used. The 6.2 millimeter implants showed significantly higher removal torque value compared to the 4.8 millimeter implants. Several critical factors are necessary for successful osseointegration of dental implants, including the primary stability and surface characteristics of the implant anatomical conditions. The primary stability of the implant, which results from the initial interlocking between alveolar bone and the body of the implant, affects the secondary stability of the implant because the later results from subsequent contact, osteogenesis, and bone remodeling. The stability of implants can be successfully assessed by the OSSEL device, which quantifies the RF. Resonance frequency is a non-invasive objective method to evaluate implant stability, and it has been validated through in vitro and in vivo studies. The technique is based on the measurement of the RF of a small piezoelectric transducer attached to an implant or abutment. The primary determinants of the primary stability of an implant are the surgical technique used, the design of the implant, and the mechanical properties of the bone tissue. The removal torque is defined as the amount of torque required to unscrew an implant from bone and is determined by the total degree of contact between the implant surface and bone. The greater removal torque values may be interpreted as the higher stability of the implants. Bovarib was used in this study and is classified as type 2 bone in other studies since it contains thick, compact bone and dense trabecular bone. Going to the conclusion, from the observed primary stability, it can be concluded that short implants were able to achieve desired primary stability and in areas with good bone quality. The use of small diameter implants can prevent the need for bone reconstruction like bone grafting or other augmentation procedures. Thank you very much. These are the references. Thank you.
Thank you. Question, yes, and if you'd wait for our colleague to bring the recording device.
Thank you, Doctor, for this nice presentation, but I have some questions, and I need your patience with me a little bit.
Go ahead.
Your study was aiming to study the implant stability. At which area? Intraoral, extraoral?
Actually, the aim is to study the primary stability to compare it with the different dimensions. So the area, it's not the concern of the study.
Actually, if you are going to use 6 millimeter lens or 5 millimeter lens, you are going to use such lenses for craniofacial implants, not intraoral implants. And that's why the area is very important, because each area will have some functional demands different than the other. This is one thing. The other thing is you stated that you are comparing type 2 bone. And type 2 bone is actually in the anterior segment, just parasymphysial of the mandible. You may find it in anterior part of the maxilla. But in areas where you are phased to insert smaller implants or shorter implants, such as the posterior maxilla or the posterior mandible, you will find either type 3 bone or type 4 bone. That's why I asked you first for which area you meant to do your study. You have done a very nice work, indeed. But I think you should have addressed this situation first.
Yeah, I can understand your concerns, but I want to just clarify that the study is just focusing to that we can get a primary stability, a good primary stability. So
Yes.
we can use this kind of implant. So we will not be forced to go for bone augmentation or sometimes in
You have referred
sinus lifting in some
you
areas.
have referred first that shorter implants in poor quality bone have faced with a lot of failures, and indeed this is true. But we don't go to bone augmentation. We have some other techniques similar to bone condensation. For example, you use osteotomies, you use ridge wideners, you use any other techniques similar than this. The importance of your study is that you are using in vitro model to compare specifically two diameters and two lengths specifically.
Yeah.
And this leads me to my next question. Why did you use the ANOVA testing for this type of results? Only because you have 4 groups?
So are you suggesting another
Student t-test to test both
groups.
diameters first, and then both lenses, and between the groups. Student t-test will give you much more valid results, because such results are not meant for ANOVA. And this is my humble remark. I'm sorry, I may be wrong, but this is my own experience, that ANOVA is for multifactorial testing, for several groups, and longitudinal follow-up of the groups, of the different time intervals, covariables, and something like this, but not just binary systems of data. It will go better with the student t-test. Thank you for your patience.
Thank you very much.